Dear Amos Professional friends, hello. I wanted to make this small video to show you what you can do with Amos Professional AGA with the current version. It will show you that you can already start to create video games that use the AGA chipset, because everything that is required to load, save and display bulbs, icons is not available. So we will start. Here is the main Amos Professional folder. I have changed many things. As you can see, the files are not the same than in the original Fonctionner repository of Amos Professional. Many things have changed, and I wanted to show you some of them. For example, the first one, the man for the AGA library. Okay. This one contains system macro and system data. You can see that I've made some change. For example, here, this variable that stores the bitplane of screen to swap when you're in double buffer did only contain 32 plus 4 bytes. And it required to store one full screen bitplane plus some screen data. This means that with 8 bitplane it was not enough. That's why I've added this, because with one long integer it's enough to store data. It fixed the problem. Here I have updated also the cop mark. It's a data structure that stores information about copy list, and that required to be updated for the same reason. Going from 6 bitplane to 8 bitplane makes storage being bigger by 2 long integer, and each time Amos Professional store the bitplane somewhere, I have to enlarge the structure. You have also here data that I have added that were not available. All this data are purely new data in Amos Professional AGA that were not available in the original Amos Professional. They are used for AGA. At this point, for example, it stores checking at startup that checks if the AGA chipset is available or not. Here you have the RGB24 8 bits 224 colors, the global AGA palette, and here you have the 224 Lowres bits of the same color palette. I wanted to show you also this one. This one is interesting because there are not this one. This one is interesting because you have the screen information. This place is the main reason why extensions that were available in the original Amos Professional Classic do no more works with AGA. Initially, this place did contain 6 and 6 bitplane, so adding AGA makes me change this for 888. Due to this, I've added 6 long integer. It makes all the data available here being shifted by 6 long integer, so 24 bytes. This means that all the extensions that were compiled for Amos Professional Classic, the original, did store in hard the information about this structure for screen. So all this data were 24 byte upper. When they change this byte, in fact, they sometimes change the bitplane. This make Amos crash. That's the main reason. For technical reason, it was not really possible to make the 2 extra bitplane be saved somewhere, because it may add more checking, more test at many places of graphic, screen, double buffer, scan swap, and other method. that may make the system slower. I prefer to keep it optimized. You also have there the original 32 color palette, that is the SS color palette. To support AGA, I added the 224 color palette. This set it represents the whole 256 height-bit AGA color palette, and the set represents the low bit for the same color palette. So you see that in the structure, all things under full 24 RGB color palette. This flag is a separator. It was required because in many methods Amos Professional copy palette from a block to screen to banks with a value set as -1 at the end of the color palette. So with this I kept compatibility, and I was able to increase the color palette system copy. Okay, so we have see first place. Now we will go in the heart of the system. I have separated fields. So concerning the Amos.library, that is now called Amos Pro AGA.library, you have the main file that is here, and you have all, not all, but most of the set of commands available here. I started to separate things. So when I will release source code for those that want to update Amos Professional once AGA will be finished and released, it will be easier to work as a team, because if you have things separated, a member of the team can work on a file and another member in another one. When the Git repository or other repository system or branches, it's easier to work when files are separated than that there is only one file containing everything. So there are often conflicts when you try to push to the repo or to merge branches. With this, it's reduce the risk. For example, the screen. I have added here all the methods that are available in this field. For example, you have the screen swap that requires the screen in register D0. Each time I must update a complex method, and where I must understand exactly what's happened, because registers are not always talkative, I added the command. So when you see, when you will see the future, when the source code will be released, information that are organized this way, exactly aligned here, alignment here, and alignment here, you know that it's a place where I have updated the method and where I have added these commands. All these commands you see here were not in the original Amos Professional source code. You can check the SS swap method in the w.s field in the original repository. You will see that there are not these commands. So I've commented many parts of the source code of Amos Professional. This method is one I fixed recently for double buffer and scan swap with AGA support. I did not try it before, so I didn't see that it didn't no more works with AGA. So now it's fixed. So you have the bitplane, the bitmap used structure. I wanted to show you another method. This one is for double buffer, to create double buffer and copy content of the original screen to its double buffer bitplane. Here is a method to put two screens in dual playfield that handle now two screens with each 16 colors. Same. Here is a method that creates screen. I have added more checking, and I have added more error message. This means that when you create a screen, now you have an error message that say you exactly what was wrong in the parameters you used. I think language is better if is more precise. When a problem occurs, it must tell you exactly what's happened. Amos Professional in the original version often put generic error message. It sometimes does not help to understand what happened and what was wrong. One of my objectives is to improve this, and every time I need to update a method, I try to add a more precise error message. For the screen creation, you have more error message that are placed around. Let's go further here. 6 new error message for dual Playfield. So now all these error message are created, and error message for graphic issue. For the screen creation, I added 10 new error message. So you can see where there are no commands, you can see that I didn't touch anything. So here's the screen. Another part that is interesting to show you is the colorless system. It's really interesting because it's there that I've inserted all the AGA support. So here are all the methods. As you can see, there are not MIT license information at the top of the file, but it will be added before release. So when I will release the source code, all fields will contain the MIT license François Lyonnais put in the original Amos Professional classic release of the source code to be in execution with the license. I show you this, but as it's not released, I did not yet put all the information, but they will be there when the source code will be released. So here are the colorless method. Okay, this method is interesting. It's one of the complex things because all these memory area where Amos Professional store information on various methods. For example, when you use a screen swap, it stores the bit plane of the screen to swap in this area. So you see here it's a calculation for the size. It corresponds to an area I showed you in the first include field that did set information for Amos. So before showing you the details of the method, I prefer to show you the creation of copper. The creation of copper is further. Yes, it's there. Initializing colorless list. Okay, so it's there. This method is called at the startup of Amos to create the head of the copper list, because it does not create the entire copper list. Amos works dynamically, so it have a startup of copper list. It set 2 copper lists, the physical one and the virtual one, and each time there is a change that is done, it's done on the virtual one and it swap. It makes the virtual one become the physical one, the used, and the one that was previously used for view is set as hidden. On the 2 copper lists at the step, Amos Professional wait at a line above the start of the display and set all the sprite information. You can see here that you have the first sprite register. It put it in the first copper list, and the second copper list, more memory too, and increase the register up to this value that is the last one. And it's a loop. It's insert all the sprite there with empty memory value, so there are no sprites displayed at this point. Once it's done, I detect the AGA chipset. If yes, I insert the global color palette, register from 32 to 255 color index. The method is simple. I have the I bits structure stored here and the global palette here to get the colors. I set bitplayne to be 8 bits mode, and then once I've set all this, I have stored A0, A1 to say it's the start of the 8 bit of the color palette. I call the method that will insert all the colors. It will use the flag set there to say that it's an 8 bit with define. Once it made the loop to insert all the color banks, it came back here. Then it stores the pointer for the low bits. It points to the low bit color palette. It set the value to low bits, and then it calls the same method again to insert all the color using bitplayne 3 low bits. Once everything done, I reset bitplayne 3 on the both copper list to be normal. So Amos Professional can populate the copper list with screens and set the color from the original register from 0 to 31 correctly without having problem. Before editing this, I get crazy color in original Amos Professional editor. So with this, everything is okay. So once it's done, the creation of the copper list is finished. You notice that the copper list is not closed with a line weight at the last line of the screen, because at this point copper list is not yet used. When copper list is set, Amos Professional call the cell populate method. The cell populate. The cell populate add update content to the screen, but this content must be set directly by the SA cop O. With this, it insert screen. So when required, when you change a screen resolution, when you open a new screen, when you delete a new screen, when you change the view size, the size of the area view or screen, when you change things concerning a screen view, I must use this method to update screen data in the copper list. So there is the complex stuff I did not entirely understand, but it stores information per lines, and with this it knows when a screen starts, when another starts, or when one finished, and it scans the list this way, so it reconstructs the view of the screen. And then the cell populate insert information concerning screen in register information. Okay, so you can see with this that there are places where I've added commands with dates representing the change I've done for the color palette. Here is the screen inserting. You can see I've added the bitplayne 3. This method is interesting because it inserts a screen in the copper list. You can see here that there was the insertion of the original color palette, and here is the insertion of the high bit of the low bit of the same color palette. Amos Professional set screen color palette in two parts. The first part set the first 16 colors from 0 to 16, and the second set that here later in the method set the second part of the color register from 16 to 31 here. On both cases I have added the low bits for the color, and each time I have to set bitplayne 3 and reset bitplayne 3 to be sure that the next screen or the next rainbow or other color manipulation will be done as it should. This method put the screen in dual Playfield mode. With AGA chipset, it handles up to 16 colors per screen. I have updated this method too. I also inserted the Amos factory dual Playfield fix that prevents the screen from make a jump when scrolling. With this, it works perfectly. I made many other changes, but now we'll run Amos to see it working. So here it is. Start. My computer is not a really powerful one, so you can see that Amiga startup is a bit slow. We run Amos Professional. Here it is. With the release, there are some source code available. You can see, for example, the dual Playfield one that open a 16 color screen, a second 16 color screen, and that set dual Playfield with 2 screen. Then it do simple scrolling until you press OK, space K. So you can see it's working with 2 screen owning each 16 color. I have put the color palette in the screen so you can see it here for the second screen and you can see it for the first one. Okay, and of course everything works correctly, even if you come here in the IDE, even if you make change, the color palette is set correctly. Everything works. We have also 266 color loading, Lowres iris. All the support I've done for AGA Color is done in Lowres in iris. I've not yet set the super higher support. It will come soonly, but everything works both low resolution and iris resolution. That means that this picture is in iris. It's not really visible, but yeah, there is an interlace system. You see it when Amos reopen editor. I will run in Lowres for most faster works. So here I load a picture. You can see the full AGA color palette and the second one. I propose you to make a test at your home when you run this demonstration if you use them on an emulator. Use a screen capture program and capture the image of the and check with a graphic editor the color palette. You will see that it's full RGB24 colors and not only RGB12 with calculation to have a smooth palette. It uses already a 24 color palette. I wanted to show you more now. You see that we can load EFF file, but if I pack this screen to a memory bank, I save pack.pick the bank. Okay, I save it on screen. I erase the bank. It's the bank, nothing. Screen close. 0. Load pack one pick at another memory bank, so you are sure it's not the same. Here it is. Screen open 0. Oh, excuse me. Curse off, flash off. It will be better. 4 equal 0 to the something. Ink E draw E comma 0 to E comma something next E. What I wanted to show you is that when you close screen, your pen screen, as I explained, the color register from 32 to 255 are global. That means that they are not reset. When the Amos open a screen, it updates only the original color palette of the screen. Why? Because if you open two of the screen and want to retain the AGA color palette when opening a new screen to uncompress data, you are sure that the new screen will not crash the AGA color palette. With it, you see that the first color set is there and the 7 ones that are AGA are A and remain unchanged. Now I will do something else. For 0 to change the color E dot E next E. Oh, excuse me. Color E. It's the original palette. And now we set the wall palette. The original Amos method works, but it's RGB12 color palette. So you can notice that when you increase color, you have 16 shades of blue here, and each time it start, it continue in the number increase multiple of 16, it increase the green value. It's because it's RGB12. If I use now the new method set RGB24 color, it will set a full RGB24 blue shade. With this you can see that you really run using full RGB24 color support. So now we will unpack the picture to the screen. The full AGA palette is restored. So now it dynamically stores in the packet screen the amount of color the screen used, that was used to create the back screen. That means that Amos initially always store 32 colors. Now it stores the amount of color. If your packet screen use 64 color, it will store 64 color. That means that if you unpack 64 colored packet screen in a 256 color, the unpack will only change the color palette from 0 to 63, and not the whole palette, only the color that are stored in the packet screen. You can see with this that the packet screen can be saved and load again, everything works perfectly. Okay, so we'll go further. Get Bob 100 64. Okay, we have get a Bob. Now we'll do a small loop. We will put the screen double buffer. It will be better, and check with can swap that everything okay. The two logic and physics bitmap are updated with the image. Now we will do a small loop. So Bob 1,0,1 the image grab weight rebel next E. Here your Bob more perfectly, no flickering, everything is okay. You can use Bob, you can use animated Bob to create your game, and this Bob use the full color palette. Look this, we have list bank, save my Bob's sphere regular. Okay, we save the Bob, erase all, bank. Okay, screen closed. 0. Load my Bob's sphere regular 1 list bank. Okay, I open the screen 0. Okay, like I said, the color palette from 32 to 255 is not changed when I close screen and open screen, so I will force it to be different. Okay, and now I put the Bob here. Oh, excuse me, it's color here. So I put the Bob on screen, but the Bob on screen use the color palette of the screen. Now I use get Bob palette. You can see that the full AGA color palette is stored in the bank list. Concerning the Spack and this Bob, I also propose you to make a test. When you do this kind of test, grab the screen with screen grabbing use tools in your computer and check with the graphic editing, you will see that the color palette is full RGB24 colors. That means that you can load screen, pack screen, grab Bob, put Bob on screen, save Bob on field, on disk, load them, everything works perfectly. So you can really start to create video games in full AGA colors or in dual playfield with 2 screens owning each 16 color using AGA color palette. The only thing that remains is that I did not yet update the fade colors. That is only a CS mode. I did not yet update the rainbow method. The fact that dual playfield, the second screen, can select the color bank, and same for Sprite. These methods are not yet done, and I've not done super iris resolution and iris resolution for Sprite and bigger Sprite than AGA support. All these features are not yet done, but I think with the ones you actually have, you can really start to create video game with. I think that it should be nice for everyone. You have also AM8 mode in Lowres and iris. This picture came from Amiga, so it will not be available in the final release of the project. It's available here only at demonstration. 2 choices will be available. The one is to keep in and to retain the author license field in the project and visible on Amos Pro, or remove it. So you have the AM8 mode that works perfectly. You have alors scrolling aussi too. This small source code only show a multi-directional scrolling, showing you that the scrolling also work perfectly. You've already seen it in the dual playfield video, but you can see it here too. The scrolling works, so nothing prevents you from starting creating game with the AGA version of Amos Professional now. Only the fact that it will be less nice because you cannot do fading from black to full color palette or from full color palette to black. But this feature will come soon, and I will use the original Amos Professional method, so you will have nothing more to do than use the original method for fading. Same for rainbow. I will probably update the method, but as there is a difference in the way you set color in RGB12 and in RGB24, I will probably add a new method to create rainbow with full RGB24 color palette. Here it is. Concerning all this now, I think I said everything about this version of Amos Professional AGA. If you want to load it, you have the link of the GitHub release repository in the description of the video. You also have the URL for the official Amos Professional website. If you encounter a problem, an issue, if you have an idea of something you like to see in Amos Professional, don't hesitate. Put an issue in the GitHub repository. So if you do this on this place and only on this place, it will concentrate all information on the same place. So we can be sure that all proposition, all proposal will be available here, and I will check if it's possible to insert it in the AGA support or not. I promise nothing, but if it's interesting and if I'm able to do it, I think I will try to make it. Don't forget, if you like this video, if you like Amos Professional X, to like this video. It will help me to be more visible, and to like the Amos Professional X channel, so you can be sure that you will have the next upcoming video, demonstration, games, or anything that is around Amos Professional. I have also ordered a playlist in the channel where I put link to all the video of Amos Professional AGA users that share video on YouTube to show you that other people already start make demonstration with Amos Professional. Don't forget that Amos Professional was originally a creation of François Lyonnais, and if you want, you can follow the author concerning his new project AOZ Studio. The link of his project is also available in the description of this video. If I remind, François also set a Patreon, so if you want to support his project, that is a brand new Amos for new computers, a new generation, not Amiga Classic, feel free to support him with his Patreon. Concerning my case, if you want to support the project, you can simply make a donation on my PayPal account. The address is in the description, and you directly have a donate button in the